day, everyone. Angie and John from Infront Consulting, an award-winning Microsoft partner since 2001. Our team of global consultants are experts in a variety of technology from System Center, Windows 10, Azure, infrastructure, and other technologies like developing our own software and management packs. Let's talk about our own software. Infront software is rooted definitely in saving time, money, or just eliminating our clients' pain. Designed from our learnings of our clients' challenges, we've developed Beekeeper to provide automation of patching. But most importantly, it validates the applications after the patching. So Beekeeper was originally developed as this automation solution for an American regional grocery chain. As a client, they were using System Center Orchestrator and multiple complex dependent runbooks. Our client's Exchange team was so frustrated in the fact that they would spend most of their Friday nights waiting for the Exchange server to be patched, only then to have to test that the Exchange application started properly and was healthy after the Exchange servers were restarted from the patching. Can you relate? Thus, Beekeeper was born. Why was it called Beekeeper? Well, if you've ever walked into a very large data center, the server sound is like humming bees, while the IT admins are like the beekeeper. Thus, that buzz sound is really hard to miss, and therefore, our solution for all of the IT operations is called Beekeeper. So, let's imagine. What would a world be like if you had 100% patching compliance every month? Your boss would probably love you, the organization would love you, but that is actually an achievable goal. Let's also imagine at the end of the patching cycle, your applications are automatically tested to make sure that they are healthy and functioning without having to wake up the application owner in the middle of the night. If you could also patch your highly available applications with zero downtime, what would that mean to you? All of this is possible with Beekeeper. We know that the big expense on patching servers is the time manually spent validating that the application is running again. While it's great to just patch, what is the time and the effort put in to making sure that the application is running properly? This is where Beekeeper can help your team. So Beekeeper and SCCM are all possible together. Some people ask us, what is the difference? And that's where I'm going to turn it over to John and let him explain how Beekeeper and SCCM go perfectly together.
Thank you, Angie. With SCCM all by itself, patching is not truly 100% automated. Just to give a quick rundown, we know that updates are released every Patch Tuesday, the second Tuesday of the month. SCCM has to be configured to distribute the patches. SCCM also needs to be configured to install the patches at your scheduled time. Some corporations do not have SCCM reboot after patching because they want to manage the downtime of their servers. And then any testing that needs to be done for the application after patching is of course a manual process. So again, the patching and distribution and installation is automated, but any pre-checks you wanted to do, any pre-maintenance you need to do are all manual with SCCM. And the application post-reboot is also manual if you cannot manage that yourself. So the question always comes along is how long are you spending on these manual checks and making sure your application is up and running. And this is where Beekeeper can help. We're going to go into a quick demo of Beekeeper, basically patching a single node, an IIS server, and I'll show you the interface and we'll walk through adding that node and the actual patching of that node. So here we are at the Beekeeper main dashboard. It's a website where we can go and add our information. As you can see right now, our dashboard is pretty clean. We have just a single type of application groups defined. There's been a few servers patched, so we have very minimal information about the patching in our center blades, giving a total of 5 minutes to patch for node, and we've saved a little over 0.19 hours for that patching. And we have our health widget on the right showing that we're talking to SCCM without any issues. Beekeeper itself is operational, and our connectivity to SCOM is fine to where we can place nodes into maintenance mode if we need to during patching. You decide whether you want that done. So we're going to go ahead and add a new server. Since it's a single server that is not an exchange tag or a failover cluster, we're going to go into our application group subcategory. We're going to tell it to add a new one. We're going to give a name for our group, and this is part of our killer app, so we'll just call it our killer app web server. We give the actual name of the server itself, and then we make sure we hit the add button to add it to our list. If we had more servers, we could continue adding, and if we had multiple servers, we could move them around using this button to move them up and down in the chain, so you could decide the order. We give an email address of the person that will be receiving the notifications, and then we can set such information as whether you want to enable maintenance mode. So when this node is patched, we want to turn on maintenance mode in SCOM for the node. If your SCOM servers aren't active, or if they're being patched at the same time, we can click this ignore failure so that we don't stop our patching on that. And then if you put it into maintenance mode, the length you want to put it in, 2 hours, 45 minutes, whatever it takes for you. And then we have some failure options as well that you can select. If patching and an update fails, we can continue after that, and if there's any failure, we can continue. You have to be careful with these options, because sometimes in a cluster scenario, you don't want to continue when a single node fails. You don't want to break your cluster. So we then save that option. It comes into our list here, and we can see that it lists out the node, our validation information, and the email information. We had talked about the pre and post patching validations, and that's where these validation tasks come into play. The types of validation tasks that we have are listed here. You can check a desired state configuration, check process, service, SQL backups, check a URL, run IIS, run a runbook, or the most powerful being run a PowerShell script to where you can run any subset of commands that you want and run a program or a SQL query. In this instance, we have a PowerShell script that we've defined to the system that we're going to add, where we are checking the IIS service, which I believe is on the next page. Yes, no, it was on the first one. I'm sorry, I missed it. It was right there. So we can add it in, and we do that through the server setting. We go back to our application group, edit under validation tasks, and then we can add that option. Right here we want to verify that the IIS service is running. We can click that here to add it, and then we'll see that it pops in. We want to do it at the end of the process, so we have all these different phases that it can be in, either when we first start pre-node maintenance, that's before we do any checking. That's even before we look to see if there's any updates to install. Once we've verified there's something to install, we can run a task before a reboot, after a reboot, when we're done with all that, or what we call post-node maintenance. That's after everything else is up. We can check that, and then we save that information, and you'll see that it now says it has a single task. So we've defined a validation point and our server. Now, to get this patching job to run, we have to create a schedule. So we can go into our schedules, and we can add a new schedule. The defined maintenance window for this server is the Saturday after Patch Tuesday. So what we can do is we name the schedule, and we'll just give it the name of our web server, and then we want to choose what would be the Saturday after Patch Tuesday. We can see that the next time would be April. The second Tuesday is the 9th, and the 14th would be that date. So we then can say it at 1 o'clock in the morning. That's fine. We have to tell it that this is a relative day. It can either be a single occurrence, a fixed day, the 5th of the month every month, or a relative day. In this case, we're saying it's occurring on the second Tuesday of the month every month, and then our offset day is where we tell it to go to Saturday, which in this case will be 4 days. And then how long we want that to be able to execute, we'll say 100 minutes just to give it some time if there's an issue. And then we can say save, and then we see that it actually has gone out there and set the date to the 14th like we had said. So once we have this in place, we now have to link the schedule to the server, and we do that through our execution jobs. So we create a new execution job, choosing our server involved, our killer app web server, go on to our schedules, and we can check the schedule we just created. I do want to go ahead and highlight this information right here. We have this execute immediately. If you were to check that option and set a timeout, it would run right then. So if there's a 0-day exploit that you've got to start patching for immediately, this is the way you could do that, is to execute immediately. Then we have checked our schedule, hit our summary button. We can see we're going against our killer app web server with our killer app web server schedule. Next execution time will be the next Saturday, and then we hit complete, and it's created the job, and we're done. Now, at this point, we would normally wait for it to execute, but I was able to run this earlier, so we can take a look real quick. And as you see, the killer app has run. It succeeded. It took 49 minutes to patch, and it applied 18 updates. So if we look at a little bit of the detail, we hit our plus button, and the overall detail of our job is on the named portion, and it can come up and give us that information. It first of all tells us that we're running, and it tells us what our execution timeout was, who's going to get the email, and so forth, and just some overview information. It went along and created the patching node information. There were no other validation tasks for on start, and then began its process of patching. It completed, executed any other items that were out there, and moved on, and then sent us an email. You can see there that it had 131 minutes remaining when it completed. And if we look at the detail on the server itself, here's where you can see we're doing some health checks. We make sure that we can contact the node by WMI, has disk space available. We look for outstanding updates, and as you saw, there were 18. Sends an email saying, hey, I'm getting ready to start, checks our process again, and if we scroll down here, you can see we've actually applied all of these updates, and our post-node maintenance task is delineated on these lines here. It started it, and you can see that it's running the PowerShell to verify it's running, and it actually put a status code in there that we can see it is running and active, and we completed fine, and we're all done. So that's a quick overview of the process of patching with Beekeeper and how I was able to automate that process. Some of the emails that I mentioned earlier were statuses along the way as it was patching, and we have reporting after the fact that you can utilize as well, and be able to check your compliance with our Power BI dashboards as well as a quick little summary report that would get emailed showing that our node is been up for less than an hour since the patching. It succeeded, but these are the patches it installed, and everything's just fine. So, like I said, that's a quick overview of Beekeeper, and then the next item we want to discuss is how Beekeeper automated that process. As we said, SCCM gets the information to the client. It is the one that gets the patches from Microsoft and deploys those patches out. Beekeeper runs pre-checks or post-checks, as we saw in this demo. And to actually do the installation, Beekeeper calls the SCCM agent. So when you schedule the patching to take place at 1 o'clock in the morning, it's going to begin right around 1 o'clock in the morning, not in the windows where SCCM could do it any time in the window. At least we know when we're actually executing. And again, as you saw in the history of the job, it managed the reboot because it was able to run the post checks afterwards, so we knew that it was coming up fine. And it called again to see if there were any more updates. So if there were, it would come back and run again if there were more updates needed, and reboot again if we needed to. And we illustrated the automation of application testing by verifying that IIS was up and running. So that one piece alone saved the time of someone having to check it. It was fully automated. And that is how Beekeeper with SCCM supplies full automation end-to-end. Angie?
Thank you, John. I think if anyone has any questions, you're probably the best person to talk to, but there's lots of people on our team that can help answer your questions. So if you have any questions about our Beekeeper software or any of our other software, please visit us at hivesoftware.ai, or you can always reach us at info@infrontconsulting.com. We'd love to answer your questions. We'd love to help you. We'd love to help you save time, get rest at night, have some quality time with your family back. If we can do any of that, just give us a shout.